Okay, let's talk about Delta Live tables as of June 2024. So today, you've got two basic patterns you can follow for any of your data engineering needs. You can go the traditional PySpark SQL route. You got to roll your own connections. You've got to handle the data, whether it's batches, streaming, different file types, JDBC connections, the works. You've got to handle all that yourselves. You also have to build your logic for both your incremental loads, full loads, maybe a type 2 type dimension load where you're keeping track of history. All of that is on you, the developer, to handle the update logic or the engineering logic entirely on your own. And yes, you could use for different frameworks to make that development a little bit easier. Like our metadata-driven framework that you'll learn about in other sessions. But for the most part today, that's an entirely manual process. Databricks' answer to that, their framework is Delta Live tables. It's a declarative language. You can define it in Python or SQL. It lets you set up views or materialized views that Databricks can then use to keep your data up to date. When you use it, DLT manages how the data is transformed, based on your query, your SQL query or your Python statement. It handles batches and streaming. It can handle your incremental loads and your full loads. It comes up with its own update logic and its own execution plan to figure out, the best way to load the data that you've defined. So with that brief introduction, let's actually jump into a really simple ingestion pipeline. So now we're over in one of my training repos. And what you see on your screen here is a simple create delta table definition. If you've used this in the past with Hive Metastore, things are pretty much the same. I'm going to go through the SQL demo here because most people are familiar with SQL. It makes for a really simple demo. In this case, I'm going to set up an ingestion table or materialized view called flight state. Actually, let's call it flight state. Yeah, flight dates. So it matches the table that we have over in an external catalog called AdventureWorks LT. And if you've used SQL Server, this is pretty familiar to you. And we're going to pull out flight state. So first, let's pop open the catalog, give you a quick tour. You can see here AdventureWorks. So here's our AdventureWorks LT external catalog. It is pointed to a SQL Server. You can tell here in the upper right, SQL Server. And if you're familiar with SQL Server, you should recognize this should look pretty familiar. You've got DBO, which is where we're going to pull that flight state from. We've got a sales LT. This is from the sales LT demo. And you'll also notice here an information schema. So this is the metadata about this database. So you've got information on columns and tables. It's not the full information schema, but with those two right there, you're pretty good to go. And we're going to circle back to that in a bit. So our flight's date data, since it's an external connection, we can see here are the columns. Here's some sample data. Takes a second to load. There's our sample data. So external table in Databricks. So let's go back to our code. So we're going to grab all the columns from AdventureWorks DBO flights date, and we want to create a Delta Live table from this. So, well, we've defined the Delta Live table. Now we want to create a Delta Live table pipeline. So let's create a pipeline. We're going to call it Silver Bronze. Product edition. You've got 3 levels here. Check out the docs for more details. I'm always a fan of go with core unless you have something in your DLT definition that requires one of the higher levels, like expectations, dependencies, stuff like that. So I'm going to go with core. I don't want this to run continuous. I'm not setting up for a stream of any kind. I want this to be triggered. Now I select my code from a repo, and all you guys are writing your code in repos, right? You're not doing it out of your workspace, are you? You'll notice I could add multiple source code, multiple notebooks or SQL statements here to this pipeline, but for this demo, we're just going to talk about the one. And real quick, if you were writing to Hive Metastore, you'd select your catalog in Hive Metastore. You could also override a location, and you could give, actually this is odd, for Hive Metastore, the catalog is the schema, so that's interesting. So let's go over here to Unity Catalog. I'm going to stick this in my Slouter catalog. I'm not going to override the storage location. I want that data written to the same location where the catalog is set up to write, but I want to write this to bronze. So down here in compute, don't need auto scaling for this little demo, so we're going to go fixed size, 1 min, 1 max, 1 worker. Again, photon acceleration, check out the documentation. My go-to is I turn it off. If you're interested to see if photon would help for your specific workload, turn it on, test it, turn it off, test it, compare the results. See if the difference in pricing is worth it. So we're good here. So we're going to go ahead and create this pipeline, and nothing's going to happen until we start it up. Now, startup takes a bit because it's going to have to find resources available in your region. I'm currently in East US 1, so this could take a few moments. So we will wait right here. So you'll notice I cut out a little bit of the wait, about 5 minutes worth. We're now complete. We've gone through all the steps. We've got flight's date. So now let's take a look at the data we gathered. So I'm going to open up another window. Go back to my repo. And let's query our ingested data. Let's connect to the one we've already got running. There we can see we've got all our data. Let's talk about a silver load. So if we do a count by year, we're going to notice some bad data. We've got years in the future. So we have flights that haven't happened yet, but we have them in our data. So we want to scrub those out and make sure they don't make it into our silver layer. So we're going to create a silver load. So it's very similar to last time. Create a refresh live table. We're going to give it a table name. Remember, the catalog and the schema are going to come from the pipeline itself. You'll notice here's all the columns. Yes, these were all typed out by hand originally, except this time we're going to add a table constraint. And this time we're going to add an expectation constraint saying that we only want records where the date occurred before the current date or the runtime. That way we don't get any future date. And in this case, if we have a row violate that rule, we're simply going to drop it. You could fail the whole pipeline here, or you could get fancy with it and do other things, but you'd have to code that out manually. Drop and fail are the only two you get built in. So we're going to define it as a select statement. So we're going to select all of those same columns back out. And this time we're going to get our data from our bronze flight date. So let's go back to workflows and DLT. And now we're going to create our silver pipeline. I'm going to set this to core just so I can show you the error that gets thrown because we are using an expectation. So let's do core, triggered. We're going to go to paths, back to the repo. This time we want our silver. And we want to write to Unity catalog. And we're going to write to my catalog. And this time we're going to change to the silver schema. Again, we don't need auto scaling, so we're going to go fixed sized with one worker. We're not going to use photon, and I'm going to try to create. When I hit start, I should get an error that says expect operations are not allowed for basic, DLT basic. So we're going to pause here again, waiting for this to complete. Another 5 minutes later, and we see the error that I was looking for before. Data quality checks are only supported in advanced or higher. So we'll go back. And it turns out advanced is the top. So got to have advanced here. We hit save. We hit start. And then there we go. And cut out a little bit more time for you there. Now we're running in advanced mode. You'll notice initializing, setting up tables. Here's our graph. And the data is actually flowing in now. So we'll wait here. 7 seconds. We moved 16,000 rows and we dropped 4,200 rows. So now we can go back over and query. Oh, wrong one. Query silver this time. So we can run see our silver data is loaded. But now we want to make sure our future dates have been removed. So select year, group by year, order by year, descending. And the latest year we have is 2024 and 181 rows. So that's a bronze and a silver load. Gold would just be another version of the silver. You can provide some kind of aggregation or some other form that you want to publish and share with others. Set up another DLT. Do keep in mind, you have to keep each DLT pipeline separate that lands in a separate catalog or schema, because you'll notice each of these pipelines can only be one catalog, one schema. So with that in mind, those are the basics of DLT pipelines as of June 2024. Thank you. Let's talk about Delta Live tables and metadata. So if you've seen previous content on Delta Live tables, you've probably seen a demo where each definition to the table was built by hand. a one by one process. But that takes a lot of time. There is an easier way. We can automate it by using metadata, or data that describes data. If you think about it, every ingestion package or process or command you've ever written is basically the same thing. It's getting data from one location, storing it somewhere else. So with that in mind, let's talk about sources of metadata. Where can you get this data to describe your data? Well, most relational database management systems do have a concept of information schema. So if you think of your SQL servers, MySQL, Oracles, and the like, they have concepts of information schema that you can go and get information about tables, columns, schemas, databases, etc. Now that you have Unity Catalog, well, Unity Catalog also has information schema. You can find it under the system catalog in a schema called information schema. In those cases where you're still dealing with Hive Metastore, while there isn't information schema, you do have the show tables, describe table, extended commands. You can extract metadata. You just would need to find a way to store it so that you could recall it without having to loop through and look for the specific table or description that you need for a given project. And finally, APIs. While it's not easily extracted, most APIs do have a demo call or example calls that you can make to their dev environment and get back a response, and you can use that to model out the description of the response. And that way you can use that to automate ingestion from your API sources. So once we know where we can get the metadata, let's talk about patterns. I mentioned ingestion before, and it's the easiest one to understand. Again, getting data from one place, storing it somewhere else. But let's build on that. Think about your data cleansing. You're going to apply some rule to a column or columns for some object. So think about if you've seen a previous demo, you may have seen me look for dates that occur in the future. Well, that's bad data, and we want to exclude that. Well, it's some piece of logic or rule applied to some table and a column in that table, and that's data cleansing. Once you start to see that pattern, if you think about remediation, it's just the next step of data cleansing. Instead of simply failing a row or failing the entire pipeline, you could take that bad data, store it in a special place, then have some human process come along and clean up that data later. Well, that's simply a pattern. Transforms are yet another pattern. Think about it. The last time you had to build a pipeline that hashed or obscured some information because it was PII or PCI, well, if it was a hash, that hash hasn't changed. It's a SHA-256 or SHA-1 or whatever you're using to mask the data. It's the same transform. You're only changing the column that you're applying it to, or maybe the columns you're applying it to. So start thinking about the pattern of the transform. Think of it as like a function. What is the function that describes the transformation that you're trying to do? And if you want to string together multiple transformations, think of each unit as a type of transformation. So think of those hashes, think of those masks, think of things like that. And finally, join patterns. Just think about the pattern. You're taking one object, one data object, like a table, joining it to another on certain columns. That's metadata. So once you have that metadata, you can now build SQL statements to automatically join objects together as you need them without having to define that logic every single time. So if you let that sink in, we're going to start a demo where we're going to show how we can use some sources of metadata in Unity Catalog, and we're going to build out a couple pipelines automatically. So here we are in my workspace. Here's that simple of a bespoke pattern. We're just a simple ingestion Delta live table. Create a refresh live table variable, and the variable is your destination table name. As select star from your source object, source catalog, source schema, source table. That's a pretty simple pattern. What if we wanted to, let's pull up our Catalog Explorer here. What if we wanted to ingest all the tables in this schema here without having to code each one by hand? It's 21 tables and views, 21. If you're doing that by hand, it's going to take you a few minutes, hours maybe, to put all those together. But there is a better way. Let's go over to my repo. And we're going to look for my ingestion pipeline generator. So AdventureWorks LT is an external catalog that points to the AdventureWorks LT database on a SQL server in my environment. I'm just going to reach in to its information schema and its information about all the tables. And here's what I find: catalog, schema, table, and type. So once we know we can reach that, if I want to get all the tables for Sales LT, simple little query, limit the table schema to Sales LT, store that in a data frame, and I'm ready to go. What we're going to do is we're going to build the output for a notebook. And if you've never cracked open a SQL notebook before, this is actually how it starts. It starts with a simple comment, -- space, Databricks notebook source with a carriage return line feed. So what I want to do is I want to take this notebook and I want to add that create or refresh live table pattern. I want to apply that pattern 21 times for each row in metadata data frame. So I spin through, but I replace the destination table name with the source table name, because in my case, I want the source and the destination table names to be the same. I just want to have that data available in my Delta Live, in my bronze zone, in my catalog. And I'm going to get that information from AdventureWorks LT, Sales LT, table name. So if I run this command, scroll to the top, there we go. I could copy all of this, save it to a SQL file on my machine, upload it to the workspace, and I would have a notebook, a SQL notebook with all this in it. But that's even that is too much work. So if we come down here, you'll notice I'm using the Databricks SDK library from Databricks. And good news, this is installed by default on every Databricks cluster. And I need two things. I need a workspace client, and I need this import format, because I need to be able to define what kind of thing I'm about to create in Databricks. So we're going to set up a path. This is where in my workspace I want to write it. So all of this is the path to my repo. I want to put the file in this output folder right here, and I want to call it generatedingest.sql. Remember, when you're uploading a SQL file, it's got to have the extension .sql. If I were creating a notebook here, no extension is necessary. The trick, though, is Databricks expects the content of that upload to be bytes, not text, not a string. So I'm going to take the output I created above, I'm going to encode it UTF-8, and then I'm going to extract bytes from that. And I'm going to store that here. Once I have those two things, I'm going to create an instance of my workspace client. It's going to use my credentials, since I'm running this from a Databricks workspace. And then I want to use that client to upload this content to a file, to a SQL file. I want it to go to my notebook path. I want it to use my output binary. For import format, I'm going to use auto here, because this is a really simple upload. We don't need to define anything more. And I went ahead and said overwrite true. So when I run this more than one time, I don't get a failure. So we're going to run that. Now, there's my generated ingest. And if we open it, you'll notice the default turned to SQL, where my normal. Actually, let's open ingest again. You'll notice my default is normally Python, but for generated ingest, I wanted it to SQL. And here are all 21 commands. No more copy and paste for me. So now let's go to workflows, DLTs. And if you've seen one of my other demos, you'll notice I already have a pipeline here for bronze. I just want to add this step to it because I want it to go to the same S-Louder bronze schema. All I have to do is come in here and say add source because I want to add this to my bronze pipeline. Go to repos, go to my repos, go to the output folder, and boom. There's my SQL file. I'm just doing a review this in case you haven't seen it before. Pipeline name, S-Louder bronze, addition core. I want it triggered. I do not want to make it a continuous batch, a continuous streaming process. S-Louder bronze. Fixed size, this is really small data we're dealing with here. One worker, no photon acceleration, save. And to see the changes, I'm going to need to start. Clear that up. This does take a few moments. Oh, lucky us. I did this close enough to another demo that resources were already available for me. So we're hopping straight into initialize. Setting up tables. And what we'll see on the next screen is we'll now have 22 tables in this pipeline instead of just the one we had previously. And there they are. And let's zoom in because that is really, really tiny. Notice here, a couple of them are already starting to go green. Starting, planning, running. Almost all of them are green. And we're starting to see our first completes. So we're going to let that keep running. In the meantime, we're going to come over here, go to our workspace, go to my repos. Actually, let's go to catalog instead. Go down to S-Louder. Let's look at bronze. 22 objects in bronze. And we're done. Again, that was a really simple example, but you really need to get that before we move on to our a little more advanced example. Let's open up a new tab. And generate. Okay, now we're going to set up a data cleansing / remediation process. So this is a lot more advanced. So on top of some metadata, we now also need to define rules. So we could set this up as a table, but for this quick little demo, I'm just going to make an array with an object, just one rule name called no future dates. And the logic is input column less than current date. If you've seen a previous manual demo of this, yep, that's where I got it from. In this case, though, I did want to make it a little more interesting. I want to apply that rule to my bronze sales order header. But for the first rule, I want to apply it to due date. The second one, I'm going to apply it to ship date. In the first case, if it fails, if due date's in the future, we're going to drop the row. If ship date is in the future, we're actually going to remediate that and kick that row over to a special table, S-Louder, silver remediate, sales order header. So I'm going to use these two extra pieces of metadata to process this for all of the tables in silver. So I want to start with solder, bronze, and I'm going to place it in my destination catalog solder. And guess what? This is also metadata. So storing this, you could automate the process of generating all of these silver workflows. So had some cleanup code there. So if we run this for every table in my source catalog, solder, where the schema is equal to bronze, and we're going to order it by catalog, schema, and table. We're going to grab that into a data frame, and then for each table, we're going to reach into source catalog, so solder, information schema, columns for the current table, schema, and catalog. And again, we're going to order by table, and we're going to order by ordinal position. This is a fancy way of saying the order of the columns. Now, for each one of those columns, we're going to do some work. So I needed to set up some strings here where I can hold on to my information, because I'm going to build out some pretty complex SQL. So for each one of those columns for a given table, if it's not the first column, I want to add a comma to the end of the column definition. So the column definition is going to be the column names of the data types being defined. So you got to have commas after the first one. And for the column list, this is just a name of the list, the name of the columns. I'm going to use this in a select statement. And I do need both, so I'm going to store both. I also found in putting this demo together, if the column type includes car, as in varchar, in varchar, that's actually a string in SQL, so I needed to override the data type from the source type to string. Otherwise, I'm just going to use the data type that it discovers in information schema. So with that out of the way, for the column definitions, include the name and the type. For the column list, just include the column name. Now, for each column, I need to see if a rule applies. So what I'm going to do is I'm going to iterate through, or loop through, these table rules. It's only 2, so it's not that bad. We're going to spin through, and if the rule pertains to the current table's catalog schema table and the current column we're on, then we want to get the rule logic from our rules collection, and we want to apply it. So if the rules action is drop or fail, that's a constraint. So we need to be able to define our constraints. So here's where we start building out the constraint. We're going to give it the rules name, and if there's ever any spaces in the rules name, we're going to get rid of it and replace it with an underscore. And then we want to be able to tell from the constraint name what column it applies to, so we're going to repeat the column name here. And since this is a data cleansing expectation, the type of the constraint is going to be expect. We're going to include the rules logic that we pulled out up here. And then on violation, we're going to perform the action, whether it's drop or fail. And if there's more than one expectation, more than one constraint necessary, then, I'm sorry, no. That's just a comma separated list. We're fine there. Here, if we have a drop of type remediate, so not drop and not fail, that's actually applied through a where clause. And in fact, we're going to have to generate 2 table statements to handle this. One for all of the rows in the source table that pass the check. Those will go on to the proper destination. And then a second create table statement to tell us to put the bad rows into that remediation table. So once we've collected all that information, we need to build SQL statements. So the first one we want to build is our DLT definition. And then the second one's going to be our remediation. So our pattern again, create a refresh live table. We're going to include source name as the destination name. And then we want to add into it our column definitions So name and type. If we have any constraints, we're going to add, if it's the second one or more, we're going to add a comma first, and then add in the constraint definitions from above. If it's just one, we're just going to add the constraint definitions. Here we go. Then we're going to add our select statement, our column list, our from statement, and then if there's a where clause, so if there's a remediate up here, we're going to create a where clause so we only keep the good rows. And then I'm going to print that out for you. Then we got to go back through the rules, and we need to look to see if we have any remediate rules. If we do, then we need to create a second table using the remediate destination, column list, table, catalog, schema, and table, where it didn't pass the root logic. And then we're going to print that. Run that. It's going to take a minute for 22 tables. And we're done. And you'll notice that I actually generated more text than you can preview at a time. So like in our previous demo, this would normally go and create us a notebook. But for this demo, I just wanted to show, create a refresh, just like before. But fortunately, we've got all the way at the bottom, we do have a demo of a rule. This is our remediation rule. So you can see it did generate sales order header, silver remediate, sales order header, same select statement, or same column definition, same select, but we have our not clause. And with this, I've shown that you can generate these queries from metadata. So I do encourage you, think more about your patterns. Think about how you can perform the same work over and over again without having to code it all by hand. And I hope this has been helpful. Thank you very much.